Hello, welcome back to my channel. Today we are going to learn chapter 10 mechanical and sound wave. So in this video we are going to discuss exercise 4 applications of the standing wave. So question number 1, a stretched wire of the length 80 cm and the mass 12 gram vibrates transversely. Wave travel along the wire with a speed of 220, 3 anti-knots. Okay, can be found in the stationary waveform in between the two fixed ends. So sketch and label the waveform of the stationary wave. So here we already mentioned 3 anti-knots. So this is the waveform of the stationary wave where we have 3 anti-knots here. Okay, so this one will be knots, knot, knot, and knot. B. Determine the wavelength of the progressive wave which moves along the wire. So we want to find the wavelength. So as we know, the total length here is actually equal to 0.8 meter and is also equal to 3 lambda over 2. Okay, so meaning that our lambda is equal to 2 over 3 times 0.8. So therefore 1.6 over 3 we will get 0.533 meter. Okay, so this is the wavelength of the progressive wave. Okay, next one we want to find the frequency. Okay, so as we know, V equals to F lambda, and they already give us V is equal to 220 meter per second. Okay, so we can find V 220. The frequency is the value that we want to find, and the wavelength is equal to 0.533 meter. So therefore, the frequency we will get 413 Hz. Okay, next one we want to find tension. Okay, so as mentioned just now, V for the string is equal to square root tension over mu, where mu is equal to mass per unit length. Okay, so we must find out what is the mu first, where m is 12 grams, so we must convert into kg. Okay, and then the length is 80 cm, so it's equal to 0.8 meter. Okay, so therefore mu we will get 0.015 kg per meter. Okay, so we substitute into the equation where V is equal to 220, tension is the value that we want to find, and mu is equal to 0.015. Okay, so tension we will get 726 Newton. Okay, next one, question number 2. A tube with 60 cm long is closed at one end. Okay, so meaning that this is a closed pipe. Resonance occur and the vibrating air column in the tube produce sound of the frequency 992 Hz. The third overtone mode is found in the air column. Okay, so meaning that third overtone here for the closed pipe is actually equal to 7 harmonic. Okay, so we can write here, this is the first harmonic, where first harmonic is equal to lambda over 4, and second harmonic we don't have, third harmonic, fourth harmonic we don't have, okay, fifth harmonic, sixth harmonic, and this is 7 harmonic. Okay, so meaning that the total length here 0.6 meter is actually equal to 7 lambda over 4. Okay, so therefore our lambda is equal to 4 over 7 times 0.6. Okay, so the wavelength that we will get here is actually equal to 0.343 meter. B. Calculate the speed of the sound in the air, where we know that V is equal to F lambda. F is given 992, and lambda is the value that we found just now, 0.343. So therefore, the speed of the sound in the air is equal to 340 meter per second. Okay, next question number 2B, part 2. Find the fundamental frequency. So as we know that 992 is actually equal to 7 harmonic, or is equal to 7 first harmonic. Okay, so we want to find fundamental frequency, meaning that we want to find the first harmonic. Okay, So 992 is equal to 7 of the first harmonic. So therefore, the fundamental frequency is equal to 992 over 7. So therefore, we will get 142 Hertz. So this is our first harmonic or fundamental frequency. Question number 3. A 2-meter long air column is open at both ends. So the frequency of the certain harmonic is given 410 Hz and the frequency of the next higher harmonic is 492 Hz. Determine the speed of the sound in the air column and we ignore the n corrections. Okay, so meaning that our f when n plus 1 is equal to 492 and when f equals to n is equal to 410 Hz. Okay, so meaning that our fundamental frequency or the first harmonic is actually fn plus 1 minus fn. Okay, so we can take 492 minus 410 Hz. Therefore, our fundamental frequency or the first harmonic is equal to 82 Hz. Okay, so this is a fundamental frequency. When we know that fundamental frequency, the length here, 2 meter, is actually equal to lambda over 2. Okay, so therefore, our lambda is equal to 4 meter. Okay, so when we want to find the speed of the sound, we know that V is equal to F lambda. So we can substitute F is equal to 82 and lambda is equal to 4. So the answer for the speed of the sound in the air column is equal to 328 meter per second. Okay, next we go to the last question, question number 4. Okay, what is the frequency of the sound emitted by an open-ended organ pipe where the length is given 1.7 meter long when the surrounding is fundamental frequency? Okay, so when we say fundamental frequency and it is an open-ended, okay, so meaning that open-ended, this is the fundamental where the length here is equal to lambda over 2. So therefore, our lambda is equal to 2L and the length of this open-ended pipe is 1.7. So it's 2 times 1.7. We will get 3.4 meter. Okay, so we want to find the fundamental where F is equal to V over lambda. V is given 340. Lambda is 3.4. Therefore, the fundamental frequency we will get 100 Hz. Okay, so that's all for today. Please watch on the next video. We will discuss on 10.5 Doppler effect. Okay, see you in the next video. Bye.